Thank you very much for joining us today. On behalf of NIOSH-supported education and research centers throughout the country, we're pleased to present the 2019 Ergonomics webinar series, offering free monthly webinars on various topics on human factors in ergonomics. This collaborative effort on behalf of each ERC's continuing education program aspires to provide access to current research supported through NIOSH ERC programs. Thank you for joining us today. Today's webinar, Assessing Heat Stress Associated Changes in Postural Balance Among Firefighters, is brought to you by University of Cincinnati ERC and Dr. Amit Bhattacharya. A few housekeeping items first. You'll be muted during this presentation. If you would like to ask a question, please enter it into the online chat or Q&A. We'll save time at the end of the presentation to address questions. This webinar will be recorded and archived for viewing on COEH Northern California's website, Facebook, and YouTube channel. At this time, I'm pleased to welcome our presenter. Dr. Amit Bhattacharya, PhD, is a professor in the Department of Environmental Health at the University of Cincinnati College of Medicine. Throughout his 25-plus-year career, Dr. Bhattacharya's sponsored research activities have involved approaching real-world human health issues by bringing together multidisciplinary teams of researchers to delve deep into understanding disease mechanisms. This has included providing new knowledge for early detection of degenerative skeletal disorders and neurodegenerative disorders associated with exposure to low-level neurotoxins. His current research includes wearable and ingestible sensors for real-time assessment of heat stress and strain among firefighters during live firefighting incidences, an fMRI study to determine the effect of hypothermia on motor and cognitive functions, the impact of environmental toxicants on the human neuromuscular system and susceptibility of developing degenerative skeletal disorders, and the design, development, and application of nanosensors, biomeds technology for early detection of neurodegenerative and degenerative skeletal disorders. Thank you so much for joining us today, Dr. Bhattacharya. At this time, I would like to turn it over to you for the presentation.
By NIOSH in general, as well as the NIOSH ERC in Berkeley, to share my research findings over the last 15 years, which is still active. I'd like to upfront thank my firefighting chief, BJ Yetter, who is a fire science professor at UC, who has helped me do what I'm going to share with you. So with that, I'm starting my presentation. And again, this next slide, as you see, there's no conflict of interest. Let's see. This is a picture of one of the data collection sites, which is a live burn facility where we visited for the last 10 plus years in collaboration with about half a dozen fire departments and their firefighters. So overview of the seminar is the heat stress / fatigue among firefighters, innovative risk assessment systems and interventions. This, what I'm going to present today, is just a synopsis of an ongoing long-term risk factors among first responders. So this is a schematic of the big picture of ongoing study. And in this study, you see the different risk factors: long, irregular work shifts, chronic heat, lack of quality of sleep, lack of rest, how it impacts different components in the physiological system, such as immune function, and cumulatively how that impacts the functional outcome of motor and cognitive abilities. However, today we cannot cover all those components, but we will do the effect of acute heat exposure and how it impacts the functional outcome of the firefighter while he is fighting fire. And the effect of also looking into irregular shift work. So that'll be the limitation of what I can present in such a short time. So on the completion of this webinar, you hopefully will be able to describe the real-time monitoring of functional outcomes of firefighters with wearable and ingestible sensors during and after live firefighting, describe the magnitude of work-related risk for firefighters, and be able to identify occupations at risk of developing hyperthermia, and describe how to predict hyperthermia among firefighters and how to control. So the last item is a product we have created, which is an app which allows the fire chief to predict which one of his firefighter might be at a risk of developing hyperthermia in advance. And I'll give you a case study of that at the tail end of this presentation. So this is one of the actual events where we collected firefighting event and using the wearable sensors, the core body temperature changes and whatever. So obviously we're going to talk about firefighters. That's where the application of heat stress is important, but there are other occupations listed in this list: construction workers, agriculture workers, miners, coalface workers, military personnel. They all have risk of heat stress, and many more occupations. So my presentation will have a discussion of many of these items you see here. The heat disorder and symptoms, I'm not going to spend a whole lot of time. Many of you probably are in this field, so you probably already know the various types of disorders and the symptoms. I'm going to mention the physiology of heat stress and how it impacts the functional abilities, and then talk about what to measure and how to measure. And eventually, for the firefighter, we're going to talk about how to use the emerging technology for early detection of hyperthermia, and at the end, of course, prevention. A little bit of background. If you look at the firefighter fact sheet, you will see only 30%, about 30% of the career firefighters are only 30% of them, and about 70% are volunteer firefighter or part-time firefighter. So due to lack of available full-time career firefighter positions, volunteer/part-time firefighters are compelled to work for multiple fire departments, resulting in high workload and rotating or irregular shifts. And we have data which you will see today, and we have published some in the various journals. The shift work in conjunction with high workload has been known to contribute to workplace-associated fatigue, which could potentially trigger sleep disorders affecting both motor and cognitive function. And we're going to talk about today also how cumulative buildup of fatigue due to combined exposure to chronic heat stress and shift work in conjunction with overexertion in hot environment can contribute to sudden cardiac death, which is unfortunately rising in the firefighters. So the magnitude of the risk for the firefighter, of course, is the high risk for sudden cardiac arrest, and one contributor is the extreme cardiovascular strain due to work demands and heat stress. So warning is this: firefighters are at a risk of dying on the job from keyword preventable cardiovascular conditions. So we're going to say a few words about the risk and how it can be prevented as we go forward in this discussion today. So based upon the NIOSH document, if you want to access more information, go down to the reference I given in the bottom of the screen, NIOSH document number 2007-133, that's where I got this. Over 75% of the deaths occurred while traveling to or from an incident, at an incident, or during training activities. So even during training, firefighters have had quite a few accidents, and some of them, unfortunately, even had death. So this presentation today is one of the training sessions of live firefighting training. Some of you might be a firefighter here. So during live burn training, they actually fight real fire. So it's not that they are doing simulation, it's actual fire. So that's what the presentation will point to at the later on discussion. So cardiac and cardiovascular effects are associated with fire smoke. And there are two common gases which cardiovascular effects are related to: carbon monoxide and hydrogen cyanide. Both, unfortunately, disrupts the bloodstream transportation of oxygen. Therefore, hypoxia sets in and impacts the heart muscle injury. And the hydrogen cyanide has an equally detrimental impact. One other chemical which is found during firefighting is the most killer is called phosgene. Phosgene is created because of different types of product being burning in the house or the building, and that when the firefighter inhales, they don't have any immediate symptoms, as opposed to hydrogen cyanide or carbon monoxide. You will have a symptom, even though we know carbon monoxide doesn't have a taste, but it does cause a symptom. Phosgene, on the other hand, doesn't cause any immediate symptom. Matter of fact, the symptoms of detrimental consequences of phosgene occurs almost 24 or 48 hours, and unfortunately there are actual death because of pulmonary edema in those people 24 to 48 hours. That's the biggest killer, which still nobody knows how to monitor in a live firefighting. So cardiac and cardiovascular effects are also associated with firefighters' work environment. As we know, in current years, for the last 20, 30 years, generally the live firefighting is less common. So suddenly the firefighter might be working in a fire department and there is a sudden alarm goes on, and that's what causes a problem. So pattern of sedentary periods is interrupted by surges of heavy physical exertion when the alarm goes on, and that causes surges of sympathetic catecholamine hormones, and that has been shown is one of the risk factors of causing acute heart attacks. And this is based upon the publication NIOSH has a reference, and you're welcome to read that in detail. One of the publications about acute heart attack because of sudden alarm and surges of heavy physical exertion and sympathetic surges cause the heart attack to begin. And that study was done by the Harvard Medical School at that time. So risk of acute heart attack will go up and has been shown to happen that way. So this is a very simplistic physiology of heat stress. When there is a hot environment, it will cause skin temperature as expected to go up, which will cause the opening of the blood vessels, which will bring the core body temperature or the hot blood from the center of the body to be distributed out to the periphery, to the sweat glands, and the sweating will increase. It's right here is increasing sweating, and that will cause the hot blood from the center of the body to go to the periphery and get dissipated by loss of heat loss of evaporation of the sweat. So that's the most and effective way humans lose heat stress conditions, by simple sweating, but sweating always is not possible. It depends upon many other factors, including the environmental conditions. Like in a hot summer right now, if the humidity is very high, your sweat evaporation will be impaired and you will not lose heat. So this is a very simplistic schematic, but most of you may already know that, but I put it in there to make you feel for what we are talking about. So we're talking about looking into the core temperature changes and how core temperature changes can bring a person's level of heat stress to the threshold. And that's what we're going to talk about with the radio pill ingested by the firefighters during their live burn testing. So fire suppression or physical exertion have been shown to cause increase in core body temperature, increase in heart rate, sweating, and fluid loss. At the same time, it causes the stroke volume, that is the amount of blood coming out of the heart with each contraction, to go down, which is bad. You want your cardiac output to be stable or higher, but in this case, heat causes to become even less available because stroke volume is down. So it decreases the cardiac output and electrolyte level goes down. And then it also increases the myocardial ischemia, that is the heart muscles lose oxygen, as we talked about certain chemicals before. The carbon monoxide and hydrogen cyanide causes hypoxia of the heart muscle, arrhythmias, heart rate irregularity, and conduction of the electrical activity in your heart muscle. There are now a lot of technology available. Some of them you're going to see presented today. Arrhythmia-related parameters can be measured and calculated now. One of the variables is called heart rate variability parameter. That's been very well tested and validated. It's a good measure or non-invasive measure of autonomic nervous system problem. During shift work also and overtime also, there is a long impact of increase in blood pressure with shift work, increase in heart disease, increase in fatigue, increase in errors and injuries. And also we have documented, and other people have, with the shift work, there is an increase in postural instability independently of other stressful conditions at work. This is one of our studies which we carried out in 2006, published in the Journal of Occupational and Environmental Medicine, showing the postural balance changes in on-duty firefighters. There is the effect of wearing the gear and the long work shift. And I have the next slide here showing you the effect of longer shift work on postural imbalance. And this is the relationship shown, postural balance, the sway parameter, which is the body sways when you stand or when you walk, and that sway parameter increases, right here, showing here, as the shift goes up. So depending upon the type of clothing you're wearing, the turnout gear or SCBA, but after 36 hours of continuous being on the shift, the potential of increase in postural balance, you see this asymptotically keeps on increasing. That is a measure or a hint of fatigue building up. And this particular study was done, which is referenced here in the bottom two publications, was done under the guidance of Fire Chief Dr. B.J. Yetter in his fire department, and then he took this information and convinced his administration to change the shift work in his department at that time from 24-hour work to 48 off, changed to 24-hour work and 72 hours off. And that helped reducing their injury and accidents in the next 2 years. But I realize, this takes away firefighter from the work, so it requires more firefighter to be hired. So there's a money issue, whether or not they can persist, they can continue to have this change in the shift to be increased duration of recovery. What we recommended, they accepted it for a while, for 2-3 years, but then I don't know whether it's still there or not, but at least Chief Yetter was able to bring this in, change, and was very positively accepted. Okay, the emergency response operations, especially those who require workers to wear semi-permeable or impermeable protective clothing like the firefighters. Obviously all the firefighter has to have protective clothing so that they do not allow any external heat to go inside the body. So that's a risk factor. Additional causal factors for heat stress are aging, body weight, physical fitness, acclimatization, metabolism, dehydration, use of alcohol, drug, and variety of medical conditions are also risk factors. In addition, the environmental factors, as you can imagine, include more than just the ambient air temperature. It includes other temperatures to be equally important risk factors. Radiant heat, air movement, conductive heat transfer, and relative humidity all affect the individual's response to the heat. Okay, this is where we come in, start to talk about the available technology which can be used, and that's what we did. And I have to share with you a very 30-second story behind why this sensor-based technology has to be used. Was raised by my colleague, Fire Chief B.J. Yetter, almost 15 years ago, when he and I started to serve in the Cincinnati Health Commissioner's Fall Prevention Committee, and that's when he asked me a simple question. As you all know, yesterday was the 50th anniversary of moon landing. I came to Cincinnati from NASA, working at NASA, a researcher, and he asked me a simple question. That referring to me, you worked at NASA and you were monitoring astronauts' heart rate in moon. Of course, I was not, but That's what the suggestion was. And if you watch the Apollo 11 actual movie came out a couple of weeks ago, they actually showed Neil Armstrong's heart rate was measured real time in 1969. So he knew that. Chief Jarrett knew that, and he said, why can I measure changes in the health condition of my firefighter across the street? On the other hand, NASA was doing it almost 50 years ago with something 200,000 miles away. So he had a point, but I couldn't find any of those sensors at that time when he asked me this question. But I was able to hunt around with my old contacts and found some of the sensor technology eventually, and that began my journey to do something which might allow the fire chief to sit in his truck outside a burning building and continuously monitor each firefighter's health condition in real time. So that some of those can be, I will be able to present and share with you. So one of the bottom line, of course, is that what is the threshold of hyperthermia? The hyperthermia very well has been studied in the literature. It requires the core temperature or the rectal probe temperature limit cannot be more than 38 degrees centigrade or 100.4 degrees Fahrenheit. And that's universally accepted threshold. And NIOSH has accepted it. And you can look it up in NIOSH's new criteria document for hot environment, which was published in 2016, and the reference is given here. In addition to that, FEMA US Fire Administration has their own heat stress criteria, which is listed in this slide. It is age dependent as a function of changes in maximum heart rate, maximum systolic blood pressure, maximum diastolic blood pressure, and they allow core temperature to go as high as 101.5, as opposed to the industrial hyperthermia is only 100.4, and plus additional symptoms. So when we collected this data of live firefighting for this discussion or presentation during live burn, they used this criteria here of FEMA. Their emergency vehicle was there, and they will use there with their emergency people standing outside the burning building while we are collecting data with the wearable sensors. So knowing that firefighters are fighting live fire across the street or whatever close, there's an urgent need to have a real-time remote monitoring of physiological workload / fatigue and heat stress to minimize cardiac death of firefighters while fighting fire. So why do we need real-time monitoring of vital signs during firefighting? Because of these following reasons right here. That is because firefighting environment and circumstances are not easily accessed and controlled. Usual occupational safety and health practices are not applicable. And individual firefighters whose judgment may be impaired by high stress and strain cannot make safe decisions about his or her, as well as for the victim they're supposed to save. So therefore, providing the incident commander, that is fire chief, with real-time physiological strain monitoring data expands his or her ability to make judgments about the exposure and work practices under changing conditions. So that's the bottom line. That is the motivation was put in at that time with my colleague, Fire Chief B.J. Yetter, and that's what kept on going, and we're still going on in this agenda. And by the way, this last statement you see here, therefore providing incident commander, this statement also applicable to any kind of conflict environment. Military is very important. Matter of fact, we are working on a DoD proposal because they want wearable sensor technology in the real enemy land. So the commander there knows 1,000 miles away what the heck is going on with his soldiers. So this has a direct impact on more different type of occupation as well, of construction workers. So impact of real-time monitoring is essentially availability of real-time monitoring system along with validated physiological criteria will permit the incident commander fire chief to make appropriate and timely decision to limit heat strain and thereby minimizing casualties among his or her firefighters at the fire scene. So good news is, after hunting through so many sensors technology, from my old contacts back at Ames, NASA, and then later on finding out, tracking down that military and NASA sold some of their licensed technology to industry. So found those people. Now it is commercially available, some of their high-tech technology. So right here, for physiological and vital sign monitoring before, during, and after live burn, these are available now commercially, right here. Many of you already know about polar wireless heart rate sensors, wearable wireless sensor for postural balance is right here. And we are using some of these. This is the radio pill, which we're going to talk about in this project we used, where the firefighter used it to swallow and continuously monitors your temperature inside you in the small intestine area, abdomen. A little bit of history behind this radio pill. When I started using it here, I found out that in mid-70s, during my project on NASA, I was using it, but didn't realize I'm going to see it again after 30-some years later. Turned out at that time, mid-70s, we had to send the technician to retrieve this radio pill because it cost $2,000 at that time per pill. Now it only costs $30, so we can simply flush down the toilet. So that's the advantage of technology getting less expensive. We also use wearable wireless 3D accelerometers and gyroscope, which has a built-in GPS with a built-in data logger. It has a SIM card, so you don't have any wires. This can measure three-dimensional motion, linear acceleration in 3D, angular velocity, and angular displacement in 3D, and the GPS. So all this multidimensional information is very useful, is wearable, is lightweight. It weighs less than your car key. We also use another sensor device called bioharness, which was a licensed technology from Army, which you can wear it like a strap. It measures it quantifies your physical, quantifies your postural balance, heart rate, and respiratory characteristics in any people who are involved in an active life or firefighting or military environment. So this particular sensor here is called inertial link sensor or bioharness system. There's a company named Zephyr. They sell it now for as cheap as $300-400 a piece. So I'm going to walk you through the currently active project where we collect this live data collection during live burn. And this is one of the examples of data collection I'm sharing with you. The physiological data collected in the live burn study was real-time heart rate with the sensor and real-time core body temperature. These are all published. The references are given here, so you're welcome to download this paper and read more about it. And this is the actual event where after they were wired up and ready to go, and they go straight into the building, which is internally the fire is lit and firefighting is going on. So this is what happens in the live burn evaluations. On the day of the data collection, our team went to the fire department like 3 or 4 a.m. in the morning, and they were given this radio pill, which has the electronics inside, this radio pill is about the size of a little bit of big fish oil tablet. And my fish oil tablet is this size, and I take it every day, 2 of them. So they were given at about 4 a.m., they will swallow it, and once you swallow, it goes down to your stomach and then eventually to the small intestine. You gotta make sure to give enough time for the radio pill to get to the small intestine. And usually it depends upon the bowel movement, time delay. It's different for different people. So we wait about 3 hours after this pill is taken, and then they come to the live burn building facility, and then we can start collecting data. And this is all wirelessly transmitted for next 72 hours. Their core temperature changes on that firefighter, and it is recorded in a recorder which they carry in their pocket. But we also have a Bluetooth version, so we can also record wirelessly across the street in a fire truck. So the protocol is shown here, simplistic. I'm going to click on all of them to talk about it. So after they come from the fire department with the radio pill, we do some baseline measurement of basic heart rate, blood pressure, and some ergonomic parameters of perception of heat stress or whatever. And then pre-scenario measurements are done right here. The scenario 1, 2, 3, they are described here. These are the actual firefighting activities they perform under each scenario, 1, 2, and 3. And after each scenario, we have a post-scenario measurements. Right here, post-scenario measurement after scenario 2, and then at the end of the whole scenario. The entire live burn activity goes on cumulatively about 58 minutes or 1 hour. And each of these scenarios doesn't last more than maybe 10 minutes. And the postural balance testing was done right before the first scenario, then end of the first scenario, then end of the second scenario, and then end of the last scenario. So this is the command center where they will come after each scenario or before the baseline to get their evaluations done and so forth. This is an example of data from the wearable heart rate sensor and the radio pill ingestible sensor results showing you, and this is in this publication, so you can read the entire work in that journal article. So this is the heart rate change, and this is the core body change as a function of duration of live burn activities. And this is the beginning of the baseline. This is the first scenario of firefighting. So you see the dotted line shows you the heart rate increases as the activity goes up, the heart rate goes up. Even during rest, initially it is high, but then with the duration of the rest, which usually ranges no more than 10 minutes to 15 minutes, it does come down. The dotted line is the heart rate. That during rest, during the scenario 2 firefighting, then it starts to go up again, heart rate. And then it comes down in the resting, and then third one is here. But important thing to see, as opposed to heart rate, which goes up and down with activity, look at the core temperature. It just keeps on rising. It doesn't even come down, even during rest period. That is the bad thing. That's called the cumulative loading of the heat stress. It's going up continuously. And that's where the discussion I will have now. What is the implication of continuous monitoring of heart rate and core body temperature showing building of heat load during live firefighting without a cooling capability? Now we have a new technology working with NIOSH Pittsburgh lab. One of my PhD students just finished his dissertation in Pittsburgh lab to use cooling system, in fact, on minimizing the core temperature to go up. Right up before and after each scenario, we did balance measurement. For balance measurement, we had the firefighter wear a sensor in his chest, which is the sensor which can quantify his body motion in 3D. So the sensor was placed on the torso, so it can measure the torso, head, and arm collectively. As you may know, if you are in the ergonomics field, it weighs close more than 60% of your body weight. So that is the biggest contributor in maintaining or not maintaining a balance. So the test was a single-legged stand balance, and this is showing you the reference vertical versus mediolateral orientation in the anterior posterior. And this is the actual data for this subject, showing you the y-axis is the duration of the test. Usually it is 30 seconds. And in this case, the sensor-based variable is the linear acceleration of the body motion in this direction, which is the anterior posterior direction, and the linear velocity of the upper torso. So what you see here is, before any firefighting started, the blue line you see is the pretty perfect upright balance, no problem. He was not moving around at all, which is good. That's what you want. But after 3 bouts of firefighting, 3 scenarios of firefighting, look at his balance, completely skewed away from the center that he's about to fall. And matter of fact, the study we finished doing now, out of 25, except for 2, they all fell after 3 bouts of firefighting. They couldn't stand on one leg for 30 seconds. So it is a very serious consequences. And this is just showing you the orientation of these sensors, how it can measure your motion in 3D. So I want to share with you a few minutes about the sensor we're using in the chest. It allows us to measure the segmental body motion contribution to postural stability, which is a method of analysis called face plane analysis approach. What does that give us is what I'm going to talk to you about in a few seconds to give you a little background. The data obtained from the sensors, which is placed on their chest, which can measure 3D acceleration. Also, it can measure 3D velocity. So I have a gyroscope and accelerometer processed by creating faceplane plot. It plots the relationship of angular velocity and angular displacement about 3D axis, as well as the linear acceleration and linear velocity plots. What is the interpretation? Within our body-based local coordinate system, human body segments with respect to its adjacent segments move in the angular mode around the reference joint. What I'm trying to explain here is that our body is built of interconnected body segments. Your forearm is connected to the upper arm at the elbow joint. So everything moves in rotation with respect to the other attached segments. So this sensor allows us to quantify the relative motion of each of the segments against the other one, and therefore, cumulatively, it contributes to the changes in the balance parameter. That's what we're measuring. So therefore, each segmental angular motions are instrumental in contributing towards the positional changes in the whole body center of mass and potentially impacting subjects' balance characteristics during postural balance test. In addition, such face plane analysis approach provides information about neuromuscular control of the 2 adjacent body segments, influencing the whole body postural balance. So we have some references. I couldn't give you the whole reference, but if somebody wants, we can send you some references. And this is the results from 26 firefighter data during live burn testing. The core body temperature was found to be significant in explaining the portion of the variation in the angular combined stability parameter that measured the upright balance, and it was statistically significant between baseline versus cumulative exposure to firefighting. And this regression results shows that static postural balance, meaning simply standing on 1 foot, one-legged stance, as indicated by this parameter called angular combined stability of the body segment, can worsen with the rising core body temperature. And this is published in a journal article. I don't see the complete reference here, but I'll be happy to send you whoever wants to read more about it. These are explanation of this particular subject's data I'm sharing with you, the one a few minutes ago we showed you. We plotted that subject's data before firefighting, prior to heat exposure here. Look at this pattern here. The wearable sensors gave us the angular velocity of his chest moving as a function of angular displacement. And look at the entire pattern from the wearable sensor. That is the amount of motion his upper torso was contributing when he had no exposure to heat stress before firefighting. After 3 events of firefighting, right here, post 3 events, the same relationship expanded. Look at this huge area expanded when you plotted the same graph from here to case after 3 events of firefighting. So this tells you even visually that this is really making this firefighter move around significantly and will be dangerous for him to maintain safe balance. And eventually, as I said, almost 80% of the firefighter couldn't finish the balance test after firefighting on 3 events. So summarizing, cumulative fatigue buildup in less than 1 hour live firefighting training session. The cumulative fatigue was built up in 83% of the firefighters. That means their core temperature kept on rising and their heart rate was also rising. As reflected by continued rise in heart rate even during resting. At the end of the rest period, after the last scenario of firefighting, the increase in all firefighters resulting heart rate ranged between 82% and 134% of their baseline heart rate, suggesting accumulated fatigue buildup. Since the firefighters were working in the hot environment, the recommended upper limit for firefighters might have to be lowered than 55 beats per minute increase for 60 minutes of live fire training. So that was a recommendation we made to the fire chiefs after we finished collecting data on 25 firefighters in this project. Going forward, we also recorded the cumulative heat exposure experienced during live burn during this training of only less than an hour, that all firefighters experienced core temperature to levels were above the industrial hypothermia level, which is 100.4 degrees. Cumulative times of above the hyperthermia limit range between 24 minutes to 2 hours to 13 minutes for all firefighters. Out of those, 3 firefighters experienced above hypothermia limit core temperature levels even longer than the entire fire training, live burn training period of 58 minutes, suggesting potential residual heat exposure. So what I'm saying here is this: end of this live burn training, which is less than 1 hour, we had 3 firefighters, because we were monitoring their core temperature even when they left the training facility and went on doing their daily business, shopping or whatever. We were able to monitor the core temperature. The core temperature never returned to the baseline for a long, long time. So that is serious consequences, because the human body core temperature is very tightly controlled by the control center in the brain, the hypothalamus. It doesn't allow your core temperature to be very much high and low. It's very, very tightly controlled to plus or minus maybe barely 1 degree. And these guys are running around doing their daily business shopping or grocery shopping, whatever, for the rest of the day with a high temperature. It's like having somebody fever with a high fever, he's running around doing other things. This is a very serious consequence. So we gave the recommendation to the firefighter chief, and that was given here. First of all, the conclusion based upon our study was acute heat metabolism. Metabolic workload is associated with increase in postural instability, larger postural sway implying poorer balance, significant increase in root mean square response suggested increased efforts to maintain balance, and increased postural instability around mediolateral, which is left to right motion axis in the front and back suggest increased risk of falling. So as I said earlier in the beginning of my presentation, that this data set we collected on 25 firefighters allowed us to create a app for individualized prediction of heat stress. And that's in this publication. You're welcome to download and read that in more detail. This is a practical and easy to use tool for early identification of firefighters who are likely to cross the threshold of hyperthermia during firefighting. We actually tested this model, this individualized predictive model, by identifying using the app a firefighter for the next testing who is at a risk of developing hyperthermia in advance. We found one through this testing with his individual data, and data were like baseline core temperature, baseline heart rate, his BMI and age and all those things, and he came out to be that he was at a risk. So then we put him through a cooling event. The cooling event was have him wear a specialized vest which has tubing, which can be embedded with compressed carbon dioxide can. So when you open the can of compressed carbon dioxide, it actually cools the surface which is touching the torso. So we reduced his core temperature. You see here initially core temperature before the cooling started was very high. And then 12 minutes of cooling caused the core temperature to bring it down all the way down to 99 degrees. So then he went into firefighting after that. And when he went into firefighting after he was cooled from very high level of 99.5 4 degrees of core temperature down to about 99 degrees. That was enough cooling which protected him during the last bout of firefighting that he never reached the hyperthermia level, and which is what was important testing to determine whether this concept works or not. And luckily, the graduate students who presented that, they won the best poster award that year. Prevention. Well, there are simple concepts of prevention, which is very well known in the literature, that modify the work, modify the environment, modify the worker by heat aquatization, and clothing. So the different clothings are not that well designed for firefighters, but there are 3 of them which is available commercially. Water-cooled garment, but it has a lot of practical problem. It's too heavy. Air-cooled is a little better, and the cooling vest. But now the new publication coming out from our team and working with the NIOSH Pittsburgh lab, that has some interesting results, so that hopefully will be coming out in a few months. So at this point, these are some of my previous graduates and how they helped me to do this study, and funding by NIOSH ERC program in Cincinnati. I want to share with you the current ongoing study. It'll take me maybe 2-3 minutes to make sure I tell you where we're going from, what we've done so far. Currently, we're doing functional MRI research to address this question or goal. The goal is to, purpose of this study is to increase our understanding of how chronic exposure to heat during firefighting activities impacts postural balance, gait, and brain function. So we are doing MRI studies on firefighters with long-term exposure to working as a firefighter versus short-term exposure, 2 groups, experienced group, inexperienced group. And this study is still going on. And here we do, in addition to regular balance, we also do gait function test, which has 2 components. A single task, meaning they're only walking around this cone. Dual task is simply when they walk, we ask them to also have a cognitive demand by asking them to subtract by 3 while walking. So you have a dual demand on the brain. It's like, you are walking and also texting and messaging while you're walking, okay? And that is something very well known in clinical environment. I've been using the dual task demand walking test in Parkinson patients and osteoporosis patients. We find this dual task demand is the best discriminator at an early dysfunction of cognitive function. So those studies are going on right now. And this is the results, the early results of static postural stability faceplane from sensor data showing this is the firefighter, one particular firefighter. He's standing on one leg with eyes open, so he doesn't fall. Entire 30 seconds, he was pretty well stable. You see this blue line, and this, each cylinder is actually his footprint. So that is his stability boundary. So by basic biomechanics of balance, his sway pattern, which is blue line, has to stay within this stability boundary defined by his footprint, the footprint which is on the ground. So the blue line shows the outline of the subject's postural sway pattern. The peach cylinder is the subject's stability boundary determined by the foot anthropometric measurement. But when we had him close his eyes, that means he now has no visual feedback regarding vertical and horizontal in his environment as a reference. He only has his vestibular system and some proprioceptor system to maintain balance. And in this particular case, you see he actually couldn't finish the 30-second test. In about 14 seconds, he fell off. His sway pattern went outside the stability boundary, the footprint. And I have a little interesting playback here. Right here. See this? This is the test. What happens from basic biomechanics, your sway pattern as we sway when we stand or walk. In the case of single stand, one-legged stand, see, he went up. So that's in 14.41 seconds, he just fell off. And this is without even firefighting in a hot environment. It is simply one group who has long-term exposure to working in a hot environment or working as a firefighter versus somebody who has a lesser number of years working as a firefighter. So remember, even though nowadays you don't have a lot of live firefighting, but you still have a lot of physically demanding job outside that creates a heat stress because of metabolic demand. And that we can measure and use it as a stress. So that's all I have. I'm open to any question answers. Michelle?
Wonderful. Thank you both, or thank you so much for your presentation. At this time, if anyone in the audience has any questions that they would like to ask, you can enter it into the webinar chat box or the Q&A box at this time. We do have one person who wanted to add a comment concerning firefighters dying from cardiovascular conditions. They wanted to take a moment to point out one of the most important operational considerations is also to make sure that we know what the reaction of the substance will be before deciding to apply any response methods. For example, if a hazardous material is flammable,
Right.
they just wanted to make sure that that got added to the conversation.
Thank you.
All right, and we have some other questions coming in.
Well, while we're waiting on that question, those questions, I just thought about something. Those of you who are familiar with firefighting, the most dangerous part of firefighting, I was told by a fire chief and other firefighters, is the overall phase, which is the phase after they suppress the fire. They go into the burning building when the fire is suppressed, and they take away their mask. That's when the carbon monoxide comes out. That's the worst thing you can do. So I don't know how to make that change, that habit, not to remove protective gear when they go in, but so tired, they want to remove everything. And that's when the exposure to carbon monoxide increases significantly. And that has been validated and shown by many researchers. The overall phase of the firefighting is the most dangerous.
Thank you. We do have a couple of questions here.
Okay.
The first, do radio pills have any side effects?
No, it is an FDA-approved radio pill, and we never had any issues. Firefighters never had any issues. Of course, there are some requirements. Not everybody is allowed to use it if they have any digestive or any occlusion in the intestine. We clear those subjects in advance. If you don't have those things, then these are acceptable candidate to take it, and it's an FDA-approved pill.
Thank you. And do they have any expiration dates?
Yeah, they do have expiration dates, so you have to watch. And just for those of you who are interested in working with this technology, my recommendation is if you're going to do a study, don't buy all your radio pill in advance, because they will expire, then you have to throw it away. So you work with this company and tell them, I'm going to buy maybe 10, but I only need now 5. And they will keep your order handy, and they'll give you the remaining 5 later.
Thank you. We do have another question. Someone was wondering how quickly you were able to complete the postural sway test after the scenarios were complete.
It's a 30-second test, 30 seconds.
Thank you. And were there any special steps taken to recruit women or other underrepresented demographics in your studies and among firefighters?
Yeah, we have data on some women firefighter, but if you look at the 10% female firefighters, so we had that representation. And also different minority were covered according to the regional distribution.
All right, thank you so much for that. Give me 1 second and I'll see who else. We do have somebody who asked, he also said the time between this scenario and the start of the test, 1 minute, 10 minutes. He was wondering, or I'm sorry, she was wondering if the recovery time, about the recovery time.
I'm sorry, the recovery in between scenarios?
Yes.
Okay, the different fire department has different protocol. One of the journal article I have referenced here, 2013, if you read it, there we compared the scenario-based micro breaks were different in one department versus another department. So I would recommend to read that. There is a difference of duration of recovery allowed. It's not recovery based upon they'll wait forever for everybody. They have a fixed time. And usually the recovery in between breaks, they don't call recovery, it's in between breaks, they probably can give you 10 minutes. But one department gave them more micro breaks, and their eventual data was more good data in a sense that they were more recovered. So we recommended their break sessions, breaks should be modified at least during live burn training.
Thank you so much. And I do have one more question here. Is there any concern about additional cardiac stress when bringing a core temperature down in a fairly short time via the use of a cooling vest and then returning to the firefighting scenario 3?
Well, that's a good question. Although we only reduced this particular firefighter who was, according to our app, which was based upon data mining modeling of predicting hyperthermia, we cooled his core temperature to from 99.4 degrees Fahrenheit to 99. So 0.4 degrees Fahrenheit. Now, based upon the physiological literature in Fahrenheit terms, that was not a huge reduction. But that's a good question to keep in mind. How low and how quickly can you apply that?
Okay, thank you so much. And I have one more question. You're finding that the CBT not dropped during rest breaks has implications for outdoor construction workers. Do you have recommendations for how long rest breaks should be in high heat conditions?
I don't. However, if you go to the OSHA website, they do have practical recommendations for what to do to minimize heat stress if you're working outdoors. Yes. Please go to the OSHA and log it in there. They have very nice bullet points. What to do for your worker who worked in the outdoors as a construction worker to minimize any heat-related problems.
Okay, thank you. And also, the last question that we'll answer, what was the age range of the subjects in the live firefighting scenarios?
I have to pull up my journal article, which is mentioned there, but Michelle, can I find my article, and I can look at it in my computer?
If anything, we can actually send that out.
Yeah.
In the follow-up email, we can send out some information on the Q&A that wasn't.
Yeah, it is on my 2013 journal article mentioned in my PowerPoint too. But we can do that. Usually these firefighters were very young. They're probably in mid-20s to mid-30s.
Okay, thank you. And thank you so much for a wonderful presentation, and thank you to all of our viewers. I do want to go ahead and take 1 second to announce our next ERC webinar is going to be held on August 21st, 2019 from 12 to 1 Pacific Standard Time. It's going to be by Andrew Merriweather, PhD, OpenSim as a platform for improving quantitative ergonomic assessments. And again, thank you so much for the presentation, and we hope to see you guys in our next one.
Thank you all. Appreciate the opportunity. Goodbye.